Okay, in this question we've got quite a messy derivative. We've got a function of x that's e to the 3x over 4x squared plus k, and we would like to show that the first derivative is this thing, 12x squared minus 8x plus 3k, with a g of x as well as a multiplier. This question is definitely best done using the quotient rule, so let's first write down the quotient rule to remind ourselves. So it starts off, obviously, we need a function of x that is a multiplier of u over v. So we can write here, this is u of x on the top and v of x on the bottom. And the quotient rule tells us that f dash of x, the first derivative, is v u dash, or du dx, minus u v dash, or u times the first derivative of v, over v squared. Okay, well, let's continue along the lines of this then. So if u is e to the 3x, then that means u dash is 3e to 3x. When you differentiate e to a function of x, the derivative of that function just comes down in front. And well, if v, I can put this down here, if v is 4x squared plus k, well then when we differentiate this, we get 8x, and the k disappears. K is just a constant in this question, so it disappears under differentiation. Now let's substitute these, u dash v, and v dash, into our quotient rule. So we should have f dash of x equals v u dash, so we're going to have 4x squared plus k, multiplied by 3e to the 3x, minus u, which is our e to the 3x, v dash, which was 8x, so actually we don't need this bracket, so we can just write 8x here, all over v squared. And our v squared is going to be this thing squared. So 4x squared plus k squared. I mean, this is still quite messy, but maybe it can look nicer in a minute. Let's think about what we could do here, because we would like to show that we can take out a factor of 12x squared minus 8x plus 3k. At the moment, we can definitely do something with this e to the 3x. So we can write e to the power of 3x, and then in these brackets, we've got 3 lots of 4x squared plus k. So that's going to be 12x squared plus 3k. And then it's take away 8x. Because we took out the e to the 3x from there. And on the bottom, we will still have 4x squared plus k all squared. Actually, here we've showed what they'd like us to show, because we've got 12x squared minus 8x plus 3k. That's exactly this. And we found that the g of x we were interested in, g of x, is just e to the 3x over 4x squared plus k all squared. So we've done part A, it's just not quite in the right order. Let's switch over to have a look at part B then. B tells us, given f of x has a stationary point, find k. And as soon as you read the word stationary point, we should definitely be thinking that means f dash of x equals 0. So let's write that down. F dash of x equals 0. What that means for us then is we'd like to solve for this thing equals 0. And let's have a think about f dash of x as a function. Well, e to the 3x, that can never be equal to 0. So we can completely forget about that. 4x squared plus k squared, can that thing ever be equal to, well, that's not what we need to be equal to 0, but for this to give us a 0 in our function, this would need to be infinitely large. So we also don't need to worry about this equaling 0 or equaling infinity, because it's on the bottom of our fraction. We can just forget about it. What we should be thinking about though is this part. This is what really concerns us for when f dash of x equals 0. This question is actually just asking us to solve 12x squared minus 8x plus 3k equals 0. We're interested in when this thing is going to give us a solution. And given it has a stationary point, I think actually in the question they told us it has at least one stationary point. So what we can say about things that equal 0 at least once, what can we say about their discriminant? Well, we can say b squared minus 4ac has to be greater than or equal to 0. That was really important for us in this question, thinking if this has got a stationary point, that means that there is at least one solution for this quadratic, and therefore using the discriminant b squared minus 4ac greater than or equal to 0. b is minus 8 in this, so b squared is going to be 64. The 4 doesn't change. A is definitely 12. And C in this question is our 3k. So times 3k. This has to be greater than or equal to 0. Let's sort some of these numbers out. 64. And actually at this point, 4 times 12 is 48. Times by 3 is 154. So 144. So 64 minus 144k is greater than or equal to 0. Let's move the 144k over to the other side. So 64 is greater than or equal to 144k. Well, what can we do here? 64 and 144 are both multiples of 8. So if we divide them both by 8, we would get 8 is greater than or equal to, definitely not 12, it should be 18k. And then if we divide through, we'll have 8 over 18, which is actually the same as 4 over 9, is greater than or equal to k. So that actually tells us to have a stationary point or more than one stationary point, k has to be less than 4 over 9 for this question.